यूट्यूब से वो यूट्यूब से नहीं है. If you want, when you come to college, I can give you.
Okay. Thank you.
Okay, so what is diffraction of light? What is interference of light? Hello?
Superposition of two waves, coherent waves.
Superposition of two waves.
From two different coherent sources of light. Right? So if there are two sources S1 and S2, these two sources are coherent. The superposition of waves from these two sources will give rise to interference. A similar phenomena is the diffraction of light. So what is diffraction? To start this, tell me first, suppose there is a slit such that its width is like reasonable in size, not so small and not so large, normal slit. And you place a source of light over here, a candle, a bulb, or anything. And you also place a screen in front of this slit. But you will see the light from rays from this source will pass through the slit and will bright the screen, like it will turn the screen bright. Suppose this ray, this is a straight line. The rays from the opposite extreme ends of the slit will reach and the screen will appear bright in this region and it will be dark above this region and also below this region. Yeah, clear? This is the normal thing you will see, right? Why? Because light travel in straight line. It will not bend in your day-to-day life. When someone is in other room, you can hear their sound or not. Suppose you are talking in one of rooms in your house, right? Some other person which is in some other room can hear you. They can hear your voice. But can the light bulb which is placed in one room can shine the other room? Can make the other room bright?
No.
Why have you ever thought about this? Why light does not, like if you place an obstacle or any object in the path of light, on the other side of that object, there will be darkness. But in case of sound, if you close the door, still sound waves will reach you. Why does this happen? This is due to diffraction. Diffraction means bending of light. Bending of light around any obstacle. Suppose you place an object in the path of light. This is called obstacle. Or if you place a slit in the path of light, it is also called an aperture. This is an aperture or slit. And this is an obstacle. So diffraction is, first thing it is bending of light. Around an obstacle or aperture. But there is a condition for that. Do you know that condition? Obstacle or aperture. Does anyone know what is the condition for diffraction of light to occur? That I told you, sound waves, they generally diffract. That is why you are able to hear the sounds which are not in the direct path from you. Whereas in case of light, in your day-to-day life experiences, you don't encounter diffraction of light so normally, like so frequently. So there must be some condition.
But this should be very small.
Yes, it is small, but also its size should be of the order of wavelength of light, such that size of aperture or obstacle is comparable to wavelength of light or wave which is undergoing diffraction. This is the condition. So we'll come to this. Okay, so if the size of the slit is large, what will happen? There will be bright region in the direct path of light and dark region above and below. But if you reduce the width of this slit, what will happen? Now there is a screen. And this is the slit. And you placed a source of light over here. What should be this ideal scenario? Light rays from the extreme points of this slit should reach the screen and make the screen brighter in this region, and other region above and below this region should be dark. But this does not happen as you reduce the size of the slit progressively. What will happen is the brightness of the screen will be reduced over here somewhat, and above or below the region there will be very blurred alternate bright and dark rays, very blurred, and width will be very large, alternate bright and dark. If we further reduce the size of slit such that it becomes comparable to the wavelength of light, what will happen then? Suppose this is the source, so this should be the reason. So in this case, the pattern will be alternate bright and dark fringes. So if you look this closely, in the above diagram, in the first figure, slit was larger, the rays were not bending at all. The region where it strike the screen is bright, and where it cannot go is dark. But when you reduce the size of slit, some of the rays reaches this forbidden region. That is why there are alternate bright fringes in addition to the dark region. Similarly here, but not all rays bend. Bending angle is very small, plus the number of rays which are bending is very small. But when you reduce the size of slit, when it becomes comparable to the wavelength of the light, it reaches the forbidden region. And why you are getting this pattern is another story. First, there is bending of light. When there is bending of light, suppose light bends like this from this point. And from another point of the slit, it goes like this. There will be superposition also. So this pattern is called diffraction pattern. So first there is bending of light, then those bent rays will undergo interference with each other and you will get a diffraction pattern.
मैम
Yes.
मैम जहाँ वो लाइट जा रहा है तो जहाँ आपने वो एरो का निशान दिया है वो वहां पर ब्राइट बनेगा ना, और सब जगह डार्क और ब्राइट दोनों बनेंगे?
नहीं, वो जहाँ जा रहा है फिर अगेन it will depend upon the path difference between the superimposing rays.
Okay.
I'll repeat this thing. So diffraction actually consists of two steps according to me. First, there is bending of light. So if the slit is very small in size, this is the screen. There is a source of light. Then light rays reaches over here on the screen. There are alternate bright and dark fringes. So first question is, why there is some brightness? There are bright regions. If there are alternate, see, light should only be in this region, there should be brightness, and above and below there should be darkness. But why in this region of darkness, there are alternate bright fringes. First question is this: why there are bright regions where normally there should be darkness? You understand the question, right? Yes or no?
Yes, ma'am.
Yes,
So
ma'am.
why there are alternate bright fringes over here? There should be complete darkness. It means light has bent around this slit such that it reaches here. That is why this region is bright. That is why I am saying that diffraction's first step is the bending of light. If it would have not bent, the light would have not bent, there would not be any brightness in this region. There would be complete darkness in this region. It means light have bent. Light has bent over here. So first, this is bending of light. So if light is bending, there are rays reaching over here. Then why there are alternate bright and dark fringes? Second question is, why there are not complete regions? Why there are alternate bright and dark? अगर light bend कर गई, वहां पे पहुंच गई, तो there should be brightness only. Then why there are alternate bright and dark and there is a pattern over there?
Ma'am, maybe because some of the light particles are reflecting back.
Reflecting back from where?
Ma'am, by touching the slit.
Touching the slit? No, I'm saying rays are coming over here. Right, the screen it is touching. There should be complete brightness then. Why there are alternate bright and dark fringes? This is the next question. The answer is in this single slit. I'm making this slit looking larger to you because I'm trying to explain you something. So I'll even make it more large. Actually, the size of slit is A and it is comparable to the wavelength of light. Okay. So now you can see this slit like composed of two portions. I'm dividing this slit. This is like this is not a original partition. You can think of this like made up of two regions. Suppose this point, ray from this point goes like this. Another ray from this point goes like this. It will be made to superimpose. When they superimpose over each other and reaches the screen, their path difference, this will tell us if there is bright or dark fringes. So basically diffraction consists of interference in the same slit. Different points of the same slit, rays from those points interfere with each other and give rise to diffraction pattern. Is this clear or should I repeat this?
Ma'am, repeat.
Okay. So in case of interference, what was the Young's double slit experiment? This is slit S1. This is slit S2. There was a screen. So light rays from these slits were superimposed and you get point P to be bright if the path difference between these two rays was n lambda. And you get this point P to be dark if the path difference is odd multiple of lambda by 2. So this was the interference pattern. Now in place of two different slits, you have a single slit. This slit S. But similar to the rays from two different slits, there are different regions in this slit. There are different. You can think of it like you're dividing the slit into different regions. there are n number of regions you can divide the slit into, where this n can approach to infinity. There are very large number of partitions of this slit, such that one partition give rise to only one ray, like this. So these rays will be superimposed over each other and give rise to diffraction pattern. So basically they are interfering with each other. The rays from different part of the same slit is undergoing interference. Is it clear or not?
मैम ब्राइट के लिए इवन चाहिए क्या मतलब डेल्टा?
Yes, I'll explain this again. I've already told you, but I'll explain again. Suppose the path difference between the rays is n lambda. So it can be lambda, 2 lambda, 3 lambda, not even any multiple integer multiple of lambda. So how will it look like? If this is one first wave, path difference should be 1 lambda. So it means another wave will start from this. But as I told you, these are not standing waves. They are propagating waves. They continuously propagating from one place to another. So it has shifted by an amount of lambda, but there is a wave which will replace this place. You understand this? This is propagating with respect to time. So when this wave is at point O, the another wave, it has shifted to point O dash at the same time. So now this path difference is between these two waves is lambda. Sorry, delta, which is equal to 1 lambda. If you look over these waves, the crest falls on crest and trough falls over trough. So it will lead to constructive interference case. That means there will be bright fringe. That is how when path difference is lambda or 2 lambda, there is constructive interference, because when the path difference is multiple of lambda, the crust always falls over the crest of other wave and the trough falls over the trough of another wave, which gives rise to this constructive interference. So it should not be even, it should be integer multiple. So there will be 1, 2, 3. Why we are taking odd multiple of lambda by 2 and not integer of lambda by 2, like 1 lambda by 2, 2 lambda by 2, and 3 lambda by 2? Because for the even values, this will be cancelled out and it will become lambda, but this is the condition for bright fringe. So that is why in the case of dark fringe, we are taking only the odd multiples of lambda by 2. If you take even multiples, the even number will be cancelled out with the 2 and you are left with n lambda. Clear?
Yes, ma'am.
यस मैम.
Okay, so I was telling you about diffraction. I'll explain one more time. Suppose this is the slit S. You divide this slit into only two parts, two portions. First one is this, second one is this. There is no discontinuity over here. You are only thinking of this slit into divided into two parts. This is the screen. So rays from all of the points on the slit will fall down on the screen. Suppose this portion, the extreme portion, a ray from this point reaches onto the screen at point P. We have divided the slit into two portions. So if you have taken the ray from this extreme position, take the ray from this extreme position of second portion also. So ray from this point is also reaching point P. When the path difference between these two rays, delta, it is equal to n lambda, the P point will be a point of bright fringe. But if this path difference between these two rays is odd multiple of lambda by 2, this point P will be a point of dark fringe. So you might ask why only these two rays are taken into account. To answer this question, this ray, earlier also I told you these are corresponding points of the two portions. So this point corresponds to this point. The next to this point, the corresponding point is, I'll denote this with different color. The next point of this portion is this. Similarly, the corresponding point, which is next to the extreme point for second portion, is this. Rays from these 2 points, suppose they are meeting at this point, which is adjacent to point P. Similarly, we can thought of this like every different point of the two regions and the corresponding point superimposed upon each other. Green point over here, rays from this meet at another point. So you can imagine all of the points of this portion superimposing over the corresponding points from this portion. Depending upon the path difference between the corresponding rays, this point P will be bright or dark. There is some difference, I'll tell you later. Is this clear up to now? If there is
Yes, ma'am.
any doubt, you can ask.
Yes, ma'am.
If there is any doubt, you can ask. Okay. So first you write the definition of diffraction, then we'll move on to next topic after this. There are two types of diffraction. I hope you are written the definition. There are two types of diffraction. First one is Fresnel diffraction. Second is Fraunhofer. You have studied this earlier, right? What is the difference between two? Who will tell what is the difference between Fresnel and Fraunhofer? Are you people there?
Yes, ma'am.
Okay, I
Yes,
thought
ma'am.
I'm speaking to myself only. So who will tell the
No.
difference between Fresnel and Fraunhofer diffraction?
Lens.
क्वेश्चन में डिटेक्टर
The first difference
इतना बड़ा
is in case of Fresnel diffraction, the source and screen, they are not far from each other. That they are some finite distance. That is why the second point is incident wavefronts are spherical because they are not far from each other. Incident wavefront is spherical. And wavefront leaving the obstacle or slit, it's also spherical. Because they are spherical wavefronts and they are not far from each other, we don't need any lens to converge the rays. So no convex lens is needed to converge the spherical wavefronts. On the other hand, Fraunhofer diffraction, in case of Fraunhofer diffraction, source and screen, they are far away from each other. How is this possible? That you are conducting an experiment and you are placing a source at infinity. How is this possible? Here, this is written over here, source is at infinity. Suppose you are conducting an experiment in lab. You want to place some source of light and that light source should be placed at infinity. How will you do that?
Ma'am, light should be parallel. Incident
Light
should
rays,
be parallel.
yes, should be parallel. How will you get parallel waves?
Rays behind
We can
ventilator
use
are
lenses.
parallel.
One of you, I'm not able to listen this.
Ma'am, we can use lenses.
Yes, we can use lens. So source is actually not at infinity. We have to get parallel rays so that it looks like that source is at infinity. So we place the source of light in front of a lens so that we get parallel wavefront. So incident wavefront on the diffracting obstacle or slit should be plane. Similarly, wavefront which is leaving from the slit is also plane. Because these are parallel rays or plane wavefronts, so we have to place a converging or convex lens to get the rays focus on the screen so that we can analyze the diffraction pattern. So you write these points.
अब ये सेकंड वाले डिफ्रैक्शन में डिफ्रैक्शन पैटर्न कैसे दिखेगा?
सेकंड वाले केस में फ्राउनहोफर डिफ्रैक्शन.
यस मैम, इसमें डिफ्रैक्शन पैटर्न कैसे दिखेगा?
Okay, so there will be a central bright fringe. I'm denoting this like this. It means this axis is the intensity axis. So there will be a central fringe, bright fringe, and there will be then alternate bright and dark fringes such that the intensity of bright fringes keeps on decreasing as we move away from the center. On the other side also similar kind of pattern, alternate bright and dark fringes such that intensity is decreasing. So I'll explain this graph a little bit. So this axis is intensity of light. So as intensity is maximum over here, we are saying that this is the central bright fringe. Here intensity is minimum at these points. I have denoted with red color. These points. Intensity is minimum, you can see. If this is the axis. So these points are a point of dark fringes or minima. And intensity at these points, I denoted with blue color. These points, intensity is not minimum, but it is also less than that of central one. These are maxima. This is called central maxima or central fringe or principal maxima. And these are secondary maxima or simply maxima. The intensity is decreasing as you are moving away from the center. We'll explain, derive this in first semester. Fraunhofer diffraction at single slit, then there will be two slits, and then there will be n number of slits. Are you still writing?
Yes, ma'am.
Done, ma'am.
Yes, ma'am.
And
Done, ma'am.
Okay. First of all, I'll give you numerical, then we'll derive this path difference tomorrow. And remaining topics later. You solve this numerical first. Very easy, this one. What's the answer? Are you solving this numerical? Ansh? Ansh Kumar Gupta? What happened? Did anyone of you solve this numerical?
Ma'am, 1.3 pi into 10 to the power 4.
Ma'am, ma'am,
Ma'am,
Yes.
4 into 10 to the power 4 radians.
8.4 into 4.
मैम 4.1 into 10 to power minus 4 आ रहा है मतलब 3.4 divided by 75 उसको बस ये
Okay.
डिवाइड कर लेंगे.
Yes. What is lambda?
And pi by 75.
हाँ वही तो
Or
पाई
15
3.1 थोड़ी ना.
nanometer. Yes, yes, yes. You all tell me your answers from here. Or 15 10 is for minus 9 meter. What's the relation between phase difference and path difference? Delta
2
is
pi by
given to
lambda
be,
is delta.
yes, 3 millimeter. So it means 3 into 10 is to power minus 3 meter. So relation is phi is equal to 2 pi by lambda into delta. We have to find the phi. So this is equal to 2 pi by, what is lambda? 450 into 10 raised to power minus 9. Multiplied by what is delta? 3 into 10 raised to power minus 3. So yeah, 150. You can report your answers. Like you can divide 1 with 75 and take the powers of 10 over there, or you can report it like 5 by 75 into 10 raised to power 6 rad. What will be the unit? Unit of 5?
Ma'am, radians.
Ma'am, radians.
Radians.
Yes, radians. So if you want to write this, those who has not solved can write this down. Next numerical we'll do tomorrow. That is some interesting numerical. This was quite easy. Second is interesting.
मैम दे दीजिए ना, हम लोग बना लेंगे.
हाँ मैम दे दीजिए ना.
ओके मैम, हो गया.
स्टेटमेंट लिख भी ली.
तो मैम वो
मैम एक मिनट रुक जाइए
Screenshot.
बस.
Screenshot. Yeah.
स्क्रीनशॉट ले लो.
Write this down आराम से.
डन मैम, हो गया.
Okay. Okay, so I'm ending the meeting. Thank you, everyone.
थैंक यू मैम.
थैंक यू.